In this PowerPoint, we're going to have a look at some of the more tricky concepts that crop up in the C1 unit. First thing that came up was this statement. It says, I can explain why we can be confident there are no missing elements in the first 10 elements of the periodic table. Right, so inherently this is not too tricky. If you have a little look here, I've got a bit of the periodic table going up to element 10. I mean, I don't really know why it says only the first 10. Because the reason for any of the others is also the same. Essentially, you should be aware that the modern periodic table is organized in order of increasing proton number or atomic number. That's the bottom one on this particular one. So hydrogen is 1, then helium 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. The proton number, of course, tells you the number of protons. You should also be aware that, of course, you can't get half a proton. Therefore, if you have all the numbers from whole numbers from 1 to 10 complete, then clearly there are not going to be any elements that are going to be discovered that will fit in between those. Okay, so here's your first example question. Oxygen and fluorine are both elements in period 2 of the periodic table, and then we just want you to give the number of protons, neutrons and electrons in each of them. That will involve you either looking up a periodic table in a book or online, so you will need to do that. And then, of course, you need to explain why there will never be an element discovered that will fit between oxygen and fluorine. Okay, the next statement that people were colouring red was this one. It says, I can describe unfamiliar chemical reactions with more complex balanced symbol equations, including state symbols. So first up, a quick reminder about state symbols. Hopefully you can remember what they are. So state symbols are either solid, denoted S, liquid, denoted L, gas with a G, and those three are generally pretty easy to remember. The one that sometimes gets people is the last one, which is AQ, which stands for aqueous or aqueous solution. That means that a substance is dissolved in water. So if you are given a chemical reaction, right, chances are, for this particular statement, that what you would need to do is add those state symbols after the necessary solid, liquids or gases or solutions, depending on what they tell you in the question. Right, so here's your example question for this. It says steam reacts with magnesium metal to produce magnesium oxide. Now, in the future, you probably will be able to work out the formula of magnesium oxide, but in this particular question, you can see that the formula is given to you, and then it says it forms magnesium oxide and diatomic hydrogen gas. Right, the word diatomic means it contains 2 atoms, so that is important when you're going to be writing the formula. And it is assumed that you know what the formula of steam is, which of course is just water, and that you can look up magnesium, or you know what magnesium is. So as you can see, this is an unfamiliar reaction, and you are asked to write a balanced symbol equation for this process, including the state symbols. So I'm hoping that you should be able to get what the state symbols are from the question above, and also that the balanced equation should be okay because you've been practicing that in previous lessons. Okay, so this was the next statement that came up. It says, I can make predictions for how an element will react when given information on another element in the same group. Right, so essentially what we're getting at here is the fact that if you have elements in the same group, first of all, you should be aware that they all contain the same number of outer electrons. This is very, very important. So what that means is if something is in group 7, right, everything in group 7 will have 7 electrons in the outer shell. If something's in group 3, everything in group 3 will have 3 electrons in the outer shell. Why is that important? Well, because it's the outer electrons that define the reactivity of an atom. So what that means is essentially if something has 7 electrons in the outer shell, all of these things have 7 electrons in group 7, therefore they are going to react in a similar way because the outer electrons define the reactivity. Okay, so that's what they're getting at here. Now, you've obviously studied group 1 and group 7, but this can hold for any group of the periodic table. So if they give you information about one element and how it reacts, you should be able to then decide that probably the other elements are going to react in a similar way. Okay, so here's your example question for this one. This might be something you just know anyway because you should have studied group 1. It says when lithium reacts with water, it floats and bubbles of gas are seen, an alkaline solution is produced. You've then got a statement that says reactivity increases down group 1. Now, there is a large part of this which would be that you would have to actually explain why that is, but we're not going to go into that here. The actual question is suggest. So suggest is basically exam speak for use the information that's been given to you and have your best guess. So suggest how sodium reacts with water. So that's your question here. Okay, this next one is looking at suggesting an appropriate separation or purification technique for an unfamiliar mixture. Right, we're going to start up by having a look at some separation techniques themselves. So the ones that you should have in the bank are filtration, which of course is how you separate a solid from a liquid. Obviously that solid is insoluble, and of course you just pour your mixture of the insoluble solid and a liquid through a filter paper, and the bit that you would want would be the solid, which would collect in the filter paper. Then evaporation or crystallization. This one of course is where you get the solid, but this time the soluble solid, from a solution. So if you had a solution containing something that was dissolved, so like dissolved copper sulfate or dissolved sodium chloride, then what you do is you put it in an evaporating basin, and then you would gently heat that. The water would evaporate and you'd be left with solid crystals in the bottom. And finally, distillation. This is the one where you separate a liquid from a mixture of liquids. And basically the reason it works is because the different liquids in that mixture will have different boiling points. So if you slowly heat up your mixture, then the one with the lowest boiling point will evaporate off first, and then you can recondense that, and that is how you separate using distillation. Now, you've also studied something called chromatography as well. That is also used to separate out dissolved solids in liquid. However, that's generally used to identify things, so I'm not going to include that one here. So here's your exam question. This one here, it says lead iodide was produced from lead nitrate and potassium iodide. The equation is shown because you're not supposed to know it, so there it is. So there's lots of information from that equation that you should be able to get. And then it says suggest an appropriate technique for isolating a sample of lead nitrate. Okay, next one. It says I can use experimental data to explain the classification of a substance as a compound or a mixture. Right, I'm not gonna lie, this doesn't really seem to come up very much in exam questions, but I'll quickly go through it anyway. So essentially what I think they're getting at here is that mixtures are, inverted commas, easy to separate, and that means using the techniques on the previous slide. So the distillation to separate the mixture of liquids, the evaporation or crystallization, and the filtration as ways of separating out solids, both soluble and insoluble. However, a compound, right, to separate that into its constituent elements, or the elements that make it up, is actually generally quite difficult, right? So you actually need to do a chemical reaction to do this. And when you do a chemical reaction on a compound, obviously you'll end up with some, hopefully if you do it correctly, you end up with the elements, and they will have very different properties to the compound that you started with. You may have done an experiment in school where you heated iron and sulfur and then looked at the iron sulfide that was produced that was very different to the elements. I don't know. So how might they ask you about this? Well, it's probably going to be a sort of situation where they give you some information and you have to try and interpret it. So it says here, an unknown solid substance was heated in a boiling tube and a colourless gas was given off. The gas was passed through lime water, which turned cloudy. Right, so first part, you need to identify the unknown solid as a compound or a mixture. Now, in order to do that, you basically want to have a bit of a read of that question and decide what it's telling you in terms of a new substance being produced or not. And then it asks you to identify the gas, and you may or may not be able to do that. It depends on your memory of the test that's mentioned there. Okay, so this one is potentially a bit trickier. It says I can use SI units and prefixes to describe the size of an atom and its nucleus in standard form. So this is essentially a bit of a maths situation. So I'm going to run through some bits and pieces here and see how we get on. Right, first of all, hopefully you appreciate that atoms are very small, and in terms of actually quantifying what that means, it says they have a radius of about 0.1 nm. Now an nm is a nanometer, and what a nanometer is 1 times 10 to the minus 9 meters. So therefore it's 0.1 nanometers, it is 1 times 10 to the minus 10 meters. And I hope you appreciate that is, well, we'll look at that in a second. So here comes some examples. Next thing is that the radius of a nucleus is less than 10,000 times smaller than the size of the atom. So the atom is tiny, but the nucleus is a lot smaller. So if this was the size of our, or the radius of our atom, then 10,000 times, so as in divide that number by 10,000, would give you 1 times 10 to the minus 14. Right, so things that we need to be aware of. First of all, this nm is what we call a nanometer, and what that is 0.00000000001 meters, which is 1 times 10 to the minus 9 meters, as in 0, point, and then 8 more zeros. Okay, so this is standard form, and I'm hoping you are familiar with this from maths. So that means the approximate radius of an atom using this up here would be as follows. So that would be in meters, yep. And then of course, that's that number in standard form. Okay, so 0 point and then 9 zeros. And that of course would be 0.1 nanometers. Okay, so you need to be able to convert between these things. When we're talking about standard form, the other thing you might see cropping up a lot is significant figures. All right, this number here would be 1 significant figure. I hope you appreciate that. All right, because there's only 1 non-zero digit there after the decimal point. Okay, approximate radius of the nucleus then. Well, right, so if this is the radius of the atom, the nucleus is 10,000 times smaller. So therefore, there's the radius of your atom in meters, divided by 10,000. Obviously, stick another 4 noughts in. There they are. However, that's a bit silly, so we write that in standard form, which of course would be 1 times 10 to the minus 14, or 0.13 zeros and then a 1. And therefore, if you wanted that in meters, that's what it would be. But if you wanted it in nanometers, that would be 0.0001 nanometers. Okay, so what are they actually going to ask you to do? Well, let's have a look at the next slide and we'll have a go. Okay, so here is the slide about the sizes of atoms. So you can see that you've been given here the radius of a potassium atom in nanometers. So this is going to be essentially probably a conversion type question. So it says, what's the diameter? So they're expecting you to know the link between radius and diameter, I'm sure you do, of a potassium atom in meters. Right, so this time you're going to have to do a unit conversion to get it from nanometers to meters. Right, and then it also says give your answer in standard form, okay, just like on the previous slide, and also to 3 significant figures. Right, so that's quite a bit to do for that little question. And the second part says gives the approximate radius of the potassium nucleus. So notice this one is the whole atom, this is the nucleus, in nanometers. So you're going to have to go back to the original bit and then give your answer to 3 significant figures as well.